This is Dr. Wood, and this is CIVL203 Dynamics. Welcome. This video is going to serve as a brief introduction to the study of dynamics, as well as to myself as we move into this class together. So to start with, I'd like to draw your attention, we're going to jump straight into it, a framework that I like us to think about as we think about our studies, not just in dynamics, but how dynamics interacts with the rest of our coursework. And so that brings me to what the classical model of education. The classical model of education is called classical because it was developed by the ancient Greeks and drove actually most of education as an idea up until the early part of the 20th century. And there's a lot of value to it. So kind of pushing back toward it. The first stage of a classical education starts with the grammar of a topic. So, for example, if we think about learning algebra the first time, when you learned algebra the first time, you learned first how to count, right? So you learned your numbers, and that really stands as the grammar stage. It's the building blocks, the pieces of knowledge that we'll work with. As you master those pieces, you learn to compare them at what we call the dialectic stage. So thinking again about algebra in the dialectic stage, you learn to make numbers interact with one another, add, subtract, multiply, divide. You learned about equalities and inequalities and those sorts of different comparisons as we went along. And then at the last stage of learning, we have the rhetoric stage. And here we go from pieces of knowledge to being able to compare those pieces of knowledge to actually being able to use them to make new arguments. And so this is where you'd get into algebra proper, where you'd have equations where you could solve for unknowns and that sort of thing. So that's kind of the process of learning. Now, when you think about your engineering education, it does the same process. So in our engineering education, if you look at the slide, our grammar stage represents math and science. So some definitions of what engineering is the use of math and science to promote, to solve problems. And so in this class, I'm going to assume you know a fair amount of math. We're going to be using derivatives and integrations. We're going to do a lot of simultaneous equation solving. And the assumption is that you know how to do those things because you've had these classes in mathematics. We're also going to be using physics. And so physicists think of things in terms of principles and laws, and that's great. We're going to be using those tools and pushing them into using them the way an engineer would use them. You're currently in the dialectic phase of your education where you're learning how to compare that math and science background the way an engineer would. So statics is going to be a big component of what we're doing in dynamics. We're going to go from everything moving to, or everything not moving to everything moving, and it'll be super exciting. I'm super excited about it. Your mechanics and materials classes, structural analysis, it all falls into this dialectic stage of learning to compare things. Because the net goal is that we get to the rhetoric stage, where we can actually start designing things in steel and concrete and soil and machines and composites and all this sort of ideas. But in order for us to do that high level rhetoric design that we all are excited to do, we have to be able to know how to compare things from that base information of math and science. And so the net goal and the net outcome in this is that you're in a story, and it's a story of growth, which means that for some of you, you might need to make a transformation in the way you think about your college education. I know for many of us, it's tempting to look at a course and to take a course and to pass the course, to master the stuff so that we can get through the final, and then to kind of mentally box it all up and put it on the shelf and pray we never have to touch it again. But in engineering, we're taking you through this sequence of courses because we want you to be able to do this top level rhetoric. You're not just learning it for the sake of learning it. So as we look at our math and science, if you haven't mastered those, you're going to get the opportunity to master those in this class. Furthermore, we're hoping that you'll master the dialectic stage, being able to compare these things and analyze a system that's in motion so that you can do that design work down the line. And so everything we're learning in this class, you can and will end up using later, particularly if you're a mechanical engineer. For civil engineering and construction engineering majors, dynamics is a little bit of a rounding out course. It doesn't immediately feed into future classes, but it's still going to be very valuable. I think particularly for our construction engineers, if you can get a good mental model going of what's happening in dynamics, you're going to be able to better analyze things as they're being built. So I'm thinking about construction equipment and aspects of the construction activity that are moving. And so that'll be a very important piece for you. Because we're in this story of growth, I want to share a little bit with you about my story so that you can then, in the comments for this video, share your story. Okay, so if we think for a moment about me, my name's Timothy Wood. You can call me Dr. Wood. I've been at the Citadel since fall of 2016. My wife, Robin, and my kids, Owen, Penny, and Eleanor, live in the Charleston area. We've really grown to love it. There's just great relationship here. I really love the civil engineering department at the Citadel, completely committed to it. My office is in the civil engineering department, 307, third floor, Letelier Hall. That's my phone number and my email address, and happy to do office hours by appointment. If you're taking this class online, shoot me an email first, and we'll set up a Zoom appointment so that I can actually see you face to face to answer any questions. I'm here to help you. Before I was at the Citadel, I was almost 10 years as a research associate at Texas Tech, looking at transportation, geotech structures problems. And so I know more about load rating reinforced concrete box culverts than probably anyone else in the world. But I love teaching. I'm glad to be here and to teach. My undergraduate was in engineering physics with a focus in structures, and that's a fantastic degree that no one knows what to do with. So naturally, I went in and got a master's of science in civil engineering, and then later the PhD in civil engineering, all while working as a research associate on those transportation problems. I originally chose engineering physics because I liked physics, but knew that I wanted to be able to actually solve problems and do work and be able to get a job. And so the engineering aspect was definitely a thing. And as I've looked at engineering more and more, the reason that I love engineering actually stems from Genesis 1, where it says, then God said, let us make man in our image, after our likeness, and let him have dominion over the fish of the sea, and over the birds of the heavens, and over the livestock, and over all the earth, and over every creeping thing that creeps on the earth. So God created man in his own image. In the image of God, he created him. Male and female, he created them. And God blessed them, and God said to them, be fruitful, and multiply, and fill the earth, and subdue it, and have dominion over the fish of the sea, and over the birds of the heavens, and over every living thing that moves on the earth. And so as an engineer, particularly as a civil engineer, my job is to help humanity be able to fill the earth and subdue it. Jokingly, I would say there is no part of the earth more subdued than a concrete parking lot. But all joking aside, civil engineers are responsible for helping humanity grow through the providing clean water, dealing with wastewater, providing transportation networks, as well as shelter in the forms of buildings. And so there's a lot of what civil engineers do that fulfill that mandate for creation. And my hope is to be able to train you as an engineer to help humanity grow, fill the earth, and subdue it. Now, I'm curious to know a little bit about you. And so in the comments below, please provide some comments. Let me know your name that you want to go by. So I work really hard to learn my students and know who they are. So if you have a nickname, or if you go by a middle name, or whatever it is you want me to call you, I'm happy to call you. For me, that's Dr. Wood. It's an appropriate relationship there. But I want to know what you want to go by. I'd like to know what your major is. There's probably some diversity here. And then finally, I want to know your motivation for studying dynamics and engineering in general. So my goal, my motivation is to see the earth filled and subdued under the dominion of man. But I want to know what your goal is. Why are you doing this? So please leave comments on the Canvas Citadel online assignment that answer these questions, and I look forward to seeing you in our class. Thanks. Bye.